Okay, 3.7, surface area of curved surfaces. So now here we're in this section, we're looking at the surface area, or the outer surface area of curved surfaces such as cylinders and spheres. So I want to show you how would the cylinder look like if you were to draw a flattened out or a 2D or a plan diagram. Uh, so start off with a cylinder here. So think of like a hollow cylinder, like a paper towel tube or a soft drink can that with the tops cut out. So you have a hollow cylinder here, okay, and you notice the top has a shape of a circle, and we might remember what the circumference of a circle is. So circumference is just this 2 pi r. Sometimes we said it was pi times diameter, but the diameter is also 2 times the radius. So we can also say 2 pi r. Now, if we make a cut along that cylinder, and then we open it up like we see here, and we just flatten out that cylinder as if it was flattening out a piece of paper, that circumference becomes then the entire length of that flat part, that flat rectangle that we just created, right? So that's 2 pi r. And the height of this can, or the height of the paper towel tube, or the height of this cylinder h, is also the height or the width here of this rectangle. So the surface area, or the area of this around the cylindrical part of the tube, is just the area that we can find from this rectangle that we flattened it out. So the area would just be 2 pi r times h, right? And then if we add the two circles on the top and the bottom, we add the areas of the circles themselves. So pi r squared is the area of a circle, but because we have a top and the bottom, it's just 2 times pi r squared. So this is the entire surface area of a cylinder. So this is area, surface area with both ends. Okay. If we wanted the surface area of just one end, so think of like an open can on the top, but a closed bottom on the bottom of the can, you would just have the same formula again, 2 pi r h, but instead of 2 pi r squared, it will just be pi r squared. So this is the surface area with one end. And if you have no ends, then your surface area becomes 2 pi r h, and that's it. So this is like the hollow, no ends. So like a tube that you can completely see from one end of it to the other. So what you're going to get on EQAO on your test is just this formula. Okay, I'm not going to give you the other ones. You're not going to get the other ones, but you should be able to know how to go from this formula to get these other two formulas in case you need to. Okay, so let's just do some examples here. I've put up a few on the page here. So looking at this first one, part B, we have a solid. The diameter of the circle here is 7 centimeters. So this is my diameter, and which means my radius is going to be half of 7, which is 3.5 centimeters. And the entire height of the can is 12 centimeters. Okay, and I know I'm saying height, but it looks like it's on its side, right? But it is still going to be considered the height of the can. So put the can standing back up, it looks like the height again. So this is treated as the height. So and it's a solid can, so we have both ends are there, both circular ends are there. So when I'm interested in finding the surface area, so let's say part B, surface area equals, pi r h plus 2 pi r squared, and all you have to do is plug in your values. R is my radius, so it's 3.5. H is my height, which is 12. And then plus in between, 2 times pi times r squared, so r is 3.5, and all of that squared. Now it's important to note that if you're using a calculator, try and look for the button that says pi, and try to use that button. And the reason why is because it's more accurate. It contains as many digits of pi that the calculator can handle, 3.14, 15, etc. So you're going to get a more accurate answer. If you just put 3.14, chances are I'll still mark it correct, but you're not going to get as accurate as an answer as you would if you just use all the digits of pi. Now, if I calculated all of this out, following BEDMAS rules and all that, your final answer here for this one should be 351.86 sorry, 300, that's the wrong one, 340.86 centimeters squared. So I ask you to pause the video for a moment and check that for yourself. Okay, so very good with that. We'll move on to part C. Here's a cylinder again that's hollow, so there's missing both ends. So if I'm interested in calculating the surface area for the cylinder, I'm only interested in using the first part of the formula, pi r h. I'm sorry, I forgot to put a 2 in front of the first one, so this is 2 pi r h. 2 pi r h, 2 pi r h. Regardless, you should still get the same answer in the end. Okay, so here 2 pi r h. So I'm going to plug in my values here. H is going to be 4.2. My radius is explicitly given. I don't have to calculate it for it. So 1.7 is my radius. So when I calculate this surface area, 2 times pi times 1.7 times 4.2, all together, I should get an answer of 44.86 centimeters squared. Don't forget square units because it's area. Okay, moving on down here, this is letter E. I have a cylinder with just a bottom but no top. It's just a can, no top, but we do have a bottom. So my surface area formula is adjusted slightly. So surface area is equal to 2 pi RH, which is the wall of that can, plus 1 bottom area, so pi r squared, instead of 2 pi r squared. So I'm not given radius though, I'm given the diameter. Diameter is 18. So if I want the radius, I have to do half of 18, which is 9 centimeters. I am given h, which is my height, 10 centimeters. Plug those into your formula. You get 2 pi times 9 centimeters for my radius times 10 centimeters for my height, plus pi times 9 squared. And I challenge you to calculate that yourself and then compare that with my answer. So pause the video for a moment and make that calculation. So hopefully you've calculated that, and your answer should be 819.96 centimeters squared. Okay, so let's now talk about some spheres. So let's look at a couple of spheres here. So the area, surface area of a sphere has a special formula as well. And I'm going to give you that formula directly. It's area, or surface area, equals 4 pi r squared. And this is the formula that we're going to use to calculate the surface area of a sphere. Now, the sphere that you're given, you have to make sure you have to find the radius. So if I'm given a sphere, and this length here is 4.5, this is the actual diameter. So if you look at the sphere, if you cut it in half, you have a circle here. And so if you remember, a diameter is the entire from one side to the other side of my circle. That's the diameter. So if I was just interested in the radius, I have to take half of 4.5. So the radius is 4.5 divided by 2, which is 2.25 meters. So recognizing that's my radius, plug it into the formula. 4 times pi times 2.25 squared. So do 2.25 squared first, then multiply your 4 pi. The answer you should get here is 63.62 meters squared. How does it change for half a sphere? Well, you take the surface area of an entire sphere, so surface area equals 4 pi r squared, but you have to divide it by 2, okay, because this is only half a sphere. Right? But by cutting it in half, you also introduce a new surface to calculate. You have to calculate the surface of this circle. This is another area you have to calculate. So I'm going to add the area of the circle. So add the new exposed surface. This is a circle. Okay. So what's my radius? Well, no matter from the center of your sphere to any end, that measurement is 9 centimeters. That is my radius. So r is equal to 9. So it's pretty simple when they give you that value. All you have to do is plug it in and calculate. So 4 over 2 can simplify to just 2. So I have here 2 pi times r squared. So if r is 9, I have to square 9 plus pi times 9 squared again. And here I get an answer of 763.41 centimeters squared. Remember, squared units because this is surface area. Okay, so those are just a few worked examples on how to calculate surface area of a cylinder and a sphere. Your task for today is to work on similar practice questions that I'm going to give you. And that ends this lesson.